In this video, we will be discussing arithmetic and geometric sequences. So an arithmetic sequence is a series of numbers formed by adding or subtracting the same number to the previous number. So the way I think of it is arithmetic is like arithmetic. It's your basic adding or subtracting that you learned in elementary school. And then with arithmetic sequences, we have a common difference. So it's the actual number that you are adding or subtracting to each term in an arithmetic sequence. And the way that I remember that a common difference goes with arithmetic is difference means subtraction, which goes with your adding and subtracting. So arithmetic is your arithmetic, your basic math that you learned in elementary school, and the difference, common difference, is the number that's part of the rule, and difference means subtraction, which goes with arithmetic. So now we have geometric. Geometric is a series of numbers formed by multiplying or dividing the same number to the previous number. So geometric is like geometry. So you start out elementary school learning about arithmetic. You're adding and subtracting, and then we add in some geometry, which is a little bit harder, and that's your multiplying and your dividing. So geometric is multiplication and division because it's those a little bit harder operations you learn after you learn adding and subtracting. And the common ratio is the number that you are actually multiplying or dividing. So that's part of that rule. Each term in a geometric sequence. So ratio in this case means division, like that fraction bar with the stuff on top and the stuff on the bottom. So a common ratio goes with multiplication and division. So if we look at this pattern, is it increasing or decreasing? If a sequence is increasing by a little, then you are adding. And if it's increasing by a lot, you are multiplying. And if a sequence is decreasing by a little, you are subtracting. And if a sequence is decreasing by a lot, then you are dividing. So let's look at these examples here. Determine the operation needed to solve the sequence. So if we look at these, this sequence is increasing. And if we look at the numbers, it's increasing by 14 to 22 and then 22 to 38. It's only increasing by a little bit. So in this case, it's going to be adding. If we look at number 2 is decreasing. And it's decreasing by a little bit at a time. So it's going to be subtracting. You try number 3 and number 4 on your own. Okay, if we look at number 3, the numbers are decreasing, and they're decreasing by a lot. We go from 48 to 3 very quickly, so that's going to be division. And if we look at number 4, the numbers are increasing, and it's increasing by a lot. We go from 5 to 3,125 very quickly, so it's multiplying. So let's go through some example problems. If we look at the first example, we have 5, 15, blank, and 35. And we know this is going to be an adding sequence because I'm telling you in the example. But let's see how we can actually figure it out. And we're going to use what's called an input-output table. So the first number that we're going to input is a 5. And after we do that, the output should be 15. So we're going to do something to 5 to get to 15. And then we're going to input 15 again. And we're missing this output here. And then that output will eventually go here, but we don't know what it is. And then we'll get to 35. And the pattern doesn't continue past 35, so we really don't need these 2 extra spaces. So What can we do to get from 5 to 15? Well, you can see, well, the pattern is increasing, and it's not increasing by very much, so I'm going to be adding 5 plus 10 is 15, and I have to follow that same pattern. 15 plus 10 will give me 25. And just to check it, I'm going to slide 25 into here. 25 plus 10 does give me 35. So my answer that goes in this blank is 25. Now, because we were adding 10, it's going to be a common difference, because remember, difference is that add, subtract 1. In the expression we're going to write, we're going to use a variable. So we're going to say x, which could be whatever number is the input, plus 10. So the input plus 10 is what is the rule. That's the expression. Let's look at the second one. The second one is the subtracting sequence. So we can see that the numbers are getting smaller. They're getting smaller by a little bit. So we're going to use our input-output table. We have 54 as our input, and then we're going to output 49. And then 49 is going to slide to here. 49 is our new input, and then our output should be 44. And we're going to slide that. 44 is the input, and then the output should be 39. And then 39 should be the input, and then we're going to get our output here. You can see they're getting smaller by a little bit, so I'm going to be subtracting. In this case, I'm going to be subtracting 5. So if I subtract 5, I get to 49, and 49 minus 5 gives me 44, and 44 minus 5 gives me 39, and 39 minus 5 lands me with 34. So 34 is the answer to the sequence that they're missing. Because I'm subtracting, it's a common difference of minus 5, because that was the rule. And the expression is going to be x, which is going to be the input, minus 5. All right, let's look at another example. The next example is a multiplying sequence. So you can see that my numbers are getting bigger. They're getting bigger very quickly, from 1 to 125 in only 4 terms. So it's multiplying, and our input is 1 with the output of 5. Then 5 moves to here. I input 5, the output should be 25. Then 25 moves, become the new input, and the output is 125. And then I'm going to slide it. 125 slides to here, and my new output is going to go here. So what can I multiply by these to get to the output I need? Well, if I multiply by 5 here, 1 times 5 is 5, 5 times 5 is 25, 25 times 5 is 125, and 125 times 5 gives me 625. And 625 is the missing number in this sequence. We are multiplying by 5 for our rule. And in our expression, we're going to use a variable. Now, instead of writing x times 5, we're going to write it as a coefficient, 5x. 5 times the input, whatever the input is. The last one we're going to look at is a division sequence, and you can see that I'm getting rather small, very fast. I'm going from 28 to 3.5 in 4 terms, so that's division. I'm going to input 28, output is 14. Then 14 moves to become the new input. 14, I'm missing that output, and then that output will slide there, and then my next output is 135. I'm sorry, 3.5. And I don't need these 2 extra spaces. So I'm getting small very quick, so it's division. What could I divide 28 by to get to 14? 28 divided by 2 is 14. And if I follow that through, 14 divided by 2 gives me 7. And if I put 7 here, 7 divided by 2 does give me 3.5. So 7 is the answer to the sequence. The rule is going to be divided by 2. And because it's division, it's going to be a ratio. And I should have circled ratio up here. Ratio is for that geometric sequence, that multiplication and division. And the expression would be x divided by 2.